I'm your chemistry teacher. Today our lecture is isotopes, and we will deal also with the calculation of atomic masses from the mass number. Objectives of today's lecture. In today's lecture, our aim to make learners able to define isotopes of an element with the help of atomic structure and atomic symbols. From this lecture, learners will also be able to calculate the relative atomic masses of an element from mass numbers and natural abundance of its isotopes. This lecture will also help students to state that isotopes of the same element have the same chemical properties. And from this lecture, learners will also be able to state that isotopes of the same element have different physical properties. Isotopes of an element. You can define isotopes as isotopes are different atoms of an element having same number of protons but different number of neutrons. Or isotopes can also be defined as the different atoms of an element having same atomic number but different mass number. Now see, this blue circle is shown as an atom, the electron cloud of an atom. The pink sphere is the nucleus of an atom. As we know, the nucleus of an atom has protons and neutrons. It has 6 protons as shown. So, with the chemical symbol on left hand side, we can write the proton number as it is written here. The nucleus of this atom has 6 neutrons as well. So the mass number is 12, that it is written on top left of the chemical symbol. This is another atom having the same number of protons. So similarly, we have written 6 on lower left of the chemical symbol. Its nucleus has 7 neutrons. So its nuclear number is 13, that is written on upper left of the chemical symbol like previously. Now see this another atom. It also has 6 protons. So its proton number is also 6, that is written on lower left of the chemical symbol. Its nucleus has 8 neutrons with 6 protons. So its mass number is 14, that is written on upper left of the chemical symbol. On right hand side we have shown a cloud of green color. This pink sphere shows the nucleus of this atom. Its nucleus has 8 protons, so its atomic number is 8, which is written on left lower left of the chemical symbol. This nucleus also has 8 neutrons, so its mass number is 16. This is another atom which has 8 protons and it has 9 neutrons, so its mass number is 17. This is another atom of the same element because it has same number of protons. Similarly, the atomic number is written on lower left of the chemical symbol. It has 10 neutrons as well, so its mass number is 18. So in this slide, we have shown 3 isotopes of carbon on left hand side, which are named according to their mass number. That is carbon 12, carbon 13 and carbon 14. While on right hand side, we have shown 3 isotopes of oxygen, which are named according to their mass number, which are oxygen 16, oxygen 17 and oxygen 18. Don't forget to subscribe. Now we will discuss similarities and differences among the isotopes of an element. All the isotopes of an element have same number of protons. If the number of protons are same, so definitely they have same atomic number because number of protons is called atomic number. The chemical symbol of isotopes of an element are same. For example, we have shown two isotopes of carbon here, carbon 12 and carbon 13, but both of these have same chemical symbol, that is C. C is the chemical symbol for carbon. Similarly, for other elements, isotopes have same chemical symbol. Isotopes also have same chemical properties because they have same number of electrons in their shells. So far, we have discussed similarities among the isotopes of an element. Now we will see the differences among the isotopes. From the definition of isotope, it is very clear that isotopes have different number of neutrons. If neutrons are different in different atoms of an element, means isotopes of an element, so definitely their mass number or nucleon number would also be different. Although we have discussed that chemical symbols of isotopes are same, C for all the carbon atoms, O for all the oxygen atoms, N for all the nitrogen atoms, but atomic symbol must have mass number along with the atomic symbol on upper left side. So atomic symbol must be different because mass number of isotopes are different. So the atomic symbols of two isotopes of carbon is written here. You can see that although the chemical symbol is same, but in atomic symbol, mass number is different. So atomic symbol must comprises chemical symbol, atomic number, and mass number. So as isotopes have different mass number, so they must have different atomic symbols. As we have already discussed, that chemical properties of an element depends on electrons in their shells and their arrangement. But physical properties of isotopes depends on their mass number. As mass number of different isotopes is different, so definitely their physical properties would also be different. Although we have already discussed the concept of atomic number and mass number, but little bit revision is necessary for further topics related to isotopes. The atomic number is represented by Z, capital Z. The number of protons present in the nucleus of an atom of an element is called proton number or atomic number. Mass number is represented by capital A. It is the sum of number of protons and the number of neutrons present in the nucleus of an atom. Mass number is also called nucleon number. Now we have a question. What do you think? Are atomic mass and mass number same terminologies? My answer is a big no. Atomic mass and mass numbers are two different but related terminologies. But how? As we have discussed that mass number is the sum of number of protons and the number of neutrons present in the nucleus of an atom, and it is represented by capital A. On the other hand, atomic mass is represented by AR. A means atomic mass and subscript R is relative. An atomic mass is the average mass of all the isotopes of an element present in the sample. But why it is called relative, we will discuss it with stoichiometry and mole concept. Now we will see how can we determine the atomic mass of an element from the natural abundance of its different isotopes. In determining atomic mass, we must have isotopic mass. Isotopic mass means the mass number of individual isotopes and their natural abundance. The natural abundance of isotopes is determined in research laboratories by using spectrometry. First, we multiply each isotopic mass by its natural abundance or given percentage. In second step, we add the figures that we obtain in first step. Finally, we divide the whole value by 100. Now you can see the formula. All the three steps that we have discussed are given here, where A with subscript R stands for relative atomic mass, whereas A is the mass number of individual isotopes. For understanding how to determine atomic mass, we should solve some problems. The first example is given here, where natural abundance and the mass number of two isotopes of chlorine are given. Here, the natural abundance of chlorine 35 is 75, so it is multiplied with 75, while the natural abundance of chlorine 37 is 25%, so it is multiplied with 25. And both of these are added together, then divided by 100. So finally we got the result, that is 35.5. AMU is the unit that is used for relative atomic mass of an element. In the similar method, we can calculate the atomic mass of neon from the natural abundance of its different isotopes as given in the example. Like previous example of chlorine, we have multiplied each isotopic mass with its natural abundance, and then these are added up together, then divided by 100. So finally we got 20.2 AMU. Now this question is related to relative atomic mass of boron from its isotopic masses and natural abundance. So try it out. Pause your video for a few minutes and then watch again. Hopefully you have calculated the correct relative atomic mass of boron. The method is similar, that we multiply the isotopic mass with the natural abundance of each isotope, similarly then added the figures and finally divided by 100. So the relative atomic mass of boron is 10.8 AMU, but in your syllabus it is simply written 11. Bromine has two most common isotopes, bromine 79 and bromine 81. Their natural abundance is 50% each, so try to calculate it. Hopefully you would have calculated and your answer would be 80 AMU. It is easier than others. Anyhow, we can understand that how to calculate, how to determine relative atomic mass from the natural abundance. But remember that you must have these two values, their isotopic mass and the natural abundance. Like, share and subscribe to learn more from video lectures. Thanks for watching.